Good evening, guys. We're doing double unit conversions tonight. And in this first problem, you will see that we have a number that looks like a conversion factor. However, we are going to convert both sets of units. So we have pounds that we are going to convert to grams. We have feet cubed that we are going to convert to milliliters. One of the things to notice with double unit conversion problems is you will have two units. So you will know that you have a double unit conversion problem when you have a number with two units that looks like a conversion factor. That needs to be changed to two different units. Now sometimes you will actually only be changing one of those units, but you will still set it up as a double unit conversion problem. So you can see that like I mentioned earlier. So we set it up as the conversion factor, what would look like a conversion factor, but instead we set that up as the given. So you see 53.5 pounds over 1 foot cubed. I usually start with the top and I want to convert pounds to grams. I know that 1 pound is 454 grams. That's the conversion factor I've memorized. When I know I'm in the right unit, I circle it oftentimes. Now what we will actually do is skip this second part. So I'm going to put my dirty eraser there, cover that up, and skip the conversion factor just so that it doesn't annoy me right now. I want to convert feet cubed to milliliters. Now feet cubed is that cubic unit. So what do I know? I know that 12 inches are in 1 foot, but I need foot cubed. So I cube everything in that conversion. That gets my feet cubed canceled. I'm in inches cubed at the bottom. I know that 1 inch is 2.54 centimeters. And again, if I cube everything in that conversion, then I get inches cubed canceled out, and that leaves me with centimeters cubed. 1 centimeter cubed is the same as 1 milliliter. Centimeters cubed cancel out. Now then, I'm going to grab my calculator, and you can see we plug in 53.5 times 454 divided by 12, y to the x3, divided by 2.54, y to the x3 equals, and on my calculator I get 0.85775794, etc. Significant figure wise, I go back to my original numbers, and that is 3 significant digits. This counts as 3. This is exact, exact, exact. So I should have 3, and the 7 makes that 7 go up. 0.858 grams. Notice there's my grams per milliliter. Now something that I try to do every time I do a problem is I try to do it twice in my calculator, just to make sure that I didn't make a mistake in the calculation. And we got the same answer twice, so that's pretty good. Odds that we're correct. Alright, the next problem. We have a patient's blood glucose, which is normal, 85 milligrams per deciliter. So that is a double unit number. 85 milligrams per 1 deciliter, and we want to convert that to pounds per gallon. So I know that I have a conversion for pounds to grams, but I don't have one for milligrams. So I'm going to convert milligrams, 10 to the third milligrams, to 1 gram. Milligrams cancel. Then I know it's 454 grams in 1 pound. There is my pound. That's what I wanted at the top. Now I'm going to just ignore these. I'm going to go over here to deciliter. And what do I know about deciliter? I know that Deciliters can be converted to liters, true, but that's not really going to help me any, because I don't remember that conversion for liters to gallons, and many of you don't know it at all. What I know is milliliters to quarts. So to do the deciliter to milliliter conversion, let's run over here on the side of our paper. Kilo, hecto, deca, base, deci, centi, milli, space, micro, space, nano. So I'm just going to be going from deci to milli. And so just to kind of show you what I'm doing here, I'm going to be going deci to milli. And why do I do that? Because I know that there are 946 milliliters in 1 quart and 4 quarts in 1 gallon. So that will get me to the gallon, but I've got to do this. And I didn't remember that just immediately. So I'm going to come over here. This is milli, this is deci. Who's bigger? Deci. So that's 1 deciliter, 1, 2, that means 10 to the second milliliter. And so by doing that, you can see deciliter canceled, milliliter cancels, quarts cancel, and there's gallons. So let's plug it in. 85 divided by 10, y to the x 3, divided by 454, divided by 10, y to the x 2, times 946 times 4. And on my calculator, 0.007085 yada yada. Do that one more time on my calculator before I pick my final answer. 85 divided by 10, y to the x 3, divided by 454, divided by 10, y to the x 2, times 946 times 4. And yes, that is what I get on my calculator. Significant figures, going to go back to original numbers. That's 2 significant figures. Exact, so this is 2, exact, 3, exact, 3, exact. So it's going to be 2. Now, these zeros are not significant. That means these 2 are my 2 significant digits. Does an 8 make a 0 go up? Yes. So 0.0071 pounds per gallon. A better way to write that is scientific notation. And just to remind you how to use that on your calculator, if you have this particular calculator, it's already there in your display. Hit second, psi, and it automatically puts it in scientific notation for you. It's a second and then that DRG button if you have the TI-30X2S. So then my answer would be 7.1 times 10 to the negative 3 pounds per gallon. So either answer is correct. It doesn't matter how you write it. Okay, this problem's a little longer. This doesn't look to be a double unit conversion problem. It's just more complex problems. So let's look at these. Patient weighs 202 pounds. So that looks like it's just a 1 unit number there. He has to receive a drug at a dosage of 35 milligrams per kilogram. That's a conversion factor, it looks to be. And that's kilogram of body weight, it tells us. So that's body. The drug is supplied as a solution that contains 15.5 milligrams of drug per milliliter, another conversion factor. And how many milliliters of the drug solution should he receive? So that means that if milliliters is what I'm looking for, and this is a conversion factor that contains milliliters, this will be my last conversion factor, because that's where I need to end up. So where do I start? Well, the only 1 unit number is the mass of the person. So a 202 pound person, and we need their body weight in kilograms. Now, if you remember the little short conversion, you can just do the 1 step. I don't usually remember that one. I'm not going to try right now. It's kind of late for me. So 1 pound is 454 grams. Pounds cancel. Know that there are 10 to the third grams in 1 kilogram. Again, grams cancel. Now I'm in kilograms. So now I have the drug dosage, 35 milligrams per kilogram of body weight. Kilograms cancel. That's the drug amount that's needed. It is delivered or supplied in a 15.5 milligram per milliliter solution. And I needed milliliters, so I'm in milliliters. Plug it in. The mass of the person, 202 times 454 divided by 10, y to the x3, times 35 divided by 15.5. Now my calculator is still in scientific notation. I'm going to take it out. That's second 4, floating decimal. And on my calculator I get 207.0825, yada yada. Real quick, just run those numbers again. I may not have done the double running through in the past videos, but just feel like it's a good idea to get in the habit of doing that. So get the same answer. 3 significant digits, 3 significant digits exact, 3, 3. There are my 3. Does the 0 make it go up? Nope. So 207 milliliters. It's a lot of drug. Okay, cigarettes. Hopefully you're not a smoker, but if you are, just a little information on what you're smoking. Nicotine, obviously, is the most common reason to smoke, is to get the nicotine. It's very addictive. So it says here that we have these cigarettes contain 15 milligrams of tar, so that's another substance that you are getting when you smoke, and 1 milligram nicotine, as compared to another cigarette brand that has 15 milligrams of tar, so that's the same, and 1.2 milligrams of nicotine. So it's a little more potent in the nicotine. If a person smoked 2 packs of Omni-Kings a day for exactly 52 weeks, so a year, how much nicotine in grams has the smoker inhaled or consumed, assuming all nicotine is consumed? So we have a problem with a lot of stuff in it. And we're not interested in the Doral or Doral cigarettes. We're only interested in the Omni-King. So just get rid of that information. That's not even part of this problem. We want to know about the Omni-King. And it says 2 packs for 52 weeks. No, that's not true. 2 packs a day. So that's the conversion factor. 52 weeks is actually the given, because that's the time frame that we're smoking 2 packs a day, and we're trying to find nicotine. Well, this is the amount of nicotine in each cigarette. So again, the tar, it's not relevant to our problem. We're not worried about that. So we have 1 milligram nicotine per cigarette. We have 20 cigarettes in a pack. We know how many packs they smoke a day, so that's a conversion factor. And 52 weeks is our given. So we smoke for 52 weeks, and we know that they are smoking 2 packs a day, but we are in weeks, so let's get that. 1 week is 7 days. Weeks cancel. Now we know that they're smoking 2 packs per day. So days cancel. Now we're in packs. There are 20 cigarettes per pack. So 20 cigarettes per 1 pack. Packs cancel. Now we're in cigarettes. And we know that that is 1 milligram rather of nicotine per cigarette. So that leaves us in milligrams of nicotine. The question asks for grams, so we want to convert that then. 10 to the third milligrams per gram. Milligrams cancel. So let's go back and plug it in. 52 times 7 times 2 times 20 we don't really need to worry about times 1. It's going to be the same. Divided by 10 y to the x3. And I get 14.56. Again, going to run that through real quick. 52 times 7 times 2 times 20 times, whoops, not, well, go ahead and put 1 since I hit times, divided by 10 y to the x3. Same thing, 14.56 grams. So in this case, significant digits, this one is kind of a tough one on significant digits. 52 weeks in a year is what we consider to be an exact number. Whether it is exact, I'm not going to dicker with that. That's just what we call it. So we're going to call that one not counting for significant figures. This does not count. They are exactly 7 days in a week. It doesn't say that they smoked exactly 2 packs a day. They did say exactly 52 weeks. Let's assume 2 packs a day is also exact, because that would be counted and we would consider that to be exact. Again, 20 cigarettes per pack would be counted because you count the cigarettes. Here we have something that actually does need significant figures used, and that would be 2. And then, of course, exact. So we need 2 significant digits in this number. Does a 5 make a 4 go up? Yes. So 15 grams of nicotine. All right. Not sure how that compares to a Juul pod. I wrote this question years before Juuls even came out, so I need to change this to that. That'll be kind of an interesting comparison. Hopefully you don't use those either, but kind of just a thought I had. All right, our last problem, then we'll be done. A typical aspirin tablet contains 5 grains. That sounds like a conversion factor to me. Aspirin tablet contains 5 grains of the pure aspirin analgesic compound. The remainder of the tablet is starch filler. How many aspirin tablets, so yes, that's going to be our last conversion factor, can be made using 1 kilogram of pure aspirin compound? And here's our conversion factor to get us from grains to grams. So we're going to start off with 1 kilogram of our pure aspirin, and we need to get that into grams so that we can use to grains, then grains to tablets. So 1 kilogram is 10 to the 3rd grams. Kilograms cancel. 1 gram is 15.4 grains. Now this is where, if you're just doing some chicken scratch, you may get your G's mixed up, so make sure you differentiate between grams and grains. And then we have 5 grains per tablet. And grains cancel, and there's tablets. So 1 kilogram times 10 to the 3rd times 15.4 divided by 5. And that's a lot of tablets. 3,080 is what I get. Let's run that through again. Also, just to note, if you started with 10 to the 3rd grams because you knew that was 1 kilogram, that would be fine. So 10 y to the x3, I'm going to start that way, times 15.4 divided by 5. And again, we get 3,080. Significant figures, that's 3, doesn't count, 3, 3, so we got lucky. It's exactly 3, just like it came out on the calculator. Do not put a decimal, and there you go. That's a lot of tablets, 3,080. So hopefully that helps. Slow me down if you need to. Have a good night.